Fantastic. So we're having some Chrome issues. It's doing strange things in presentation view at the moment. So the slides are a little bit smaller than they should be, but let's get on. My name is Mandy Waite. I'm a developer advocate for the Google Cloud Platform. And we're going to be talking today. Well, first, thanks for JFocus for inviting me along to speak. And also thanks to everybody who's come along to listen to me speak. I'm going to be talking about building mobile backends in the cloud using something called the Mobile Backend Starter. And because we're going to be talking mostly about server-side code, mobile backends in the cloud, there is going to be some Android development component to this talk as well. And in order to help that along, we've actually developed an application for this particular talk. It's a very, very, very simple application. Don't expect too much of it, but you can get access to it from the Play Store. It's called Mobile Backend Starter Sample. So if you search for Mobile Backend Starter, you'll find it, or you can find it at that URL there. I've also got this URL on the next slide. But let's say it's very, very simple, so don't expect too much from it. So we may have to do some repairs to the microphone mid-talk, but hopefully it won't take very long. So let's talk about development, and particularly about Android development. How many people are developing Android applications? Quite a few of you. Okay, right, cool. So the way this goes is that you watch all of the talks by the Android gurus. You see Nick Butcher, Roman Gee giving talks. You watch the YouTube videos. You read the tutorials. You read the blog posts. Then you read and implement the design guidelines. Then you test across dozens of devices, mobile phones, tablets, etc. And then you deploy a beta version of your application to the Play Store, and you have 0 crashes, 0 ANRs, everything looking good. So you're done, right? No more work to do. Well, what if the killer feature of your application was the ability to synchronize this alarm clock across multiple devices? What if you had a language application you'd written that was completely standalone initially, but then you added features using some kind of mobile backend that allowed users to actually work together with each other, interact with each other, and actually learn from each other and learn with each other. Those kind of features require mobile backends. But the server-side stuff is boring, right? Okay? So, or if it's not boring, it's hard, it's difficult to do. When I say boring, you probably want to focus on your user interface code. You want to focus on your application features. You don't want to spend time worrying about server-side stuff. And it's also hard to do. It's difficult to do. It's very complicated. Building all of those server-side components and such like, and building the software stacks, configuring it, maintaining it, it's really hard. But what if it's just like 3 lines of code? So here we're just basically inserting some data into a data store in the cloud. Very, very simple, a very simple abstraction. Is that really simple enough? You can always build these kind of things yourself. And I love this slide because it reminds me of the old days when we used to have to configure systems and software stacks. All of these boxes kind of represent things that have been horrors to all of us throughout our lives. You can also anticipate your load. Your load may vary across the length of time of your application. You may have quick instance.
There you go.
Oh, okay. It was a simple case of tightening up. Okay. All right, brilliant. Okay, so good. No more noises. Okay, so anticipating your load. You may have huge peaks in load traffic demand on your application. How do you handle those? What about when your application's doing nothing? What about when you have expensive server-side equipment sitting around doing nothing, costing you money, but not actually doing anything or making you any money? How do you handle linear growth? How do you handle exponential growth in load? So it kind of begs the question, why would you want to build mobile backend services when somebody else can build them for you? And we're talking about services such as the ability to store data in the cloud, preferences and shared state that can be shared across devices. So when a user goes from one device to another, they get exactly the same experience on the application. What about the ability to share messages between users as well, between mobile users? Event notifications too. So when a state change occurs on the client side or the server side, how is that propagated? Authentication, the ability to identify users and to associate data with users. Also autoscale, a massively important feature. How do you handle those changes in load that we saw on the previous slide? This is kind of the life of a startup. Most of you have been through this kind of thing at least once in your life. We generally start on the very left-hand side, building things in our garage, or in our kitchen, or in our bedrooms. But we're now migrating towards the right-hand side of this particular slide. We're moving into the realms of infrastructure as a service. People provide us with virtual machines in the cloud, operating systems in the cloud. And also as far as platform as a service, where people are providing entire software stacks for us in which we can run our application code. And that leads us to App Engine, which is Google's platform as a service offering. And how many people are familiar with App Engine? Yeah, quite a few of you. Okay, excellent. So App Engine, platform as a service offering, it gives you software stacks in the cloud, effectively. And the software stacks are called runtimes, language runtimes. And we have 4 language runtimes currently. We have Java, we have Python, we have PHP, and we have Go. These are completely managed for you. Some of the key features of App Engine, I'm not going to go into all of them, but it's very simple to scale. It handles that auto-scale pattern we looked at earlier very, very well. It can respond rapidly to increased demand, and it can also bring down, remove instances so you don't pay for things that you're not using. It's also very easy to get started with. It's free to start. You don't have to enter any billing information to get started. It also has a local development environment that comes with an SDK, and we have SDKs for all 4 of the languages that we support. And it offers access to massive service abstractions. Service abstractions are all of these cloud-scale services that we have internally at Google. Things like Memcache, data storage, all of the APIs that we have. And these software stacks are fully managed for you as well. You don't have to worry about providing patches, providing updates, applying patches, that kind of thing. And the whole thing is operated and run by Google SREs, Site Reliability Engineers, 24/7. These guys have pagers and they get woken up in the middle of the night to go and fix App Engine for you when it breaks. Hopefully, that doesn't happen very often. App Engine also has access to many cloud-scale services. On the Datastore side of things, we have Cloud Datastore. This is the Google internal Datastore exposed to App Engine. It's a NoSQL Datastore, schemaless completely, and very, very scalable. You don't have to worry about scale with the Datastore. It will effectively scale infinitely for you. We also offer Cloud SQL, which is MySQL, managed MySQL instances in the cloud, and Google Cloud Storage, which is a bucket-based store that allows you to store objects. You can store up to 5 terabytes an object, any amount of data that you like. App Engine also has access to its own services such as Memcache, Task Queue, cron jobs, user service for managing user accounts, and mail, and other services such as PageSpeed. And now we're going to talk about mobile backend services in addition to App Engine, services that can be used to develop mobile backends. Oh, excuse me. Grapes. Okay, so cloud endpoints. So how many people are familiar with cloud endpoints? Okay, not so many of you. That's really strange. It's a really, really amazing product. So cloud endpoints effectively allows you to expose your application code as an API, as a RESTful API. What you do is you annotate your server-side code, or you can generate endpoint classes from your models, very, very simply using tools. And these annotations actually tell a runtime component of App Engine that you want to expose these methods, these classes, as an API. And that RESTful API runs on the same infrastructure that Google's APIs run on. So Google Maps, YouTube, Google+, exactly the same infrastructure that all of our APIs run on. The APIs are completely discoverable as well, which means you can download a discovery document, which is a JSON file that describes the API. Then from that point, it's very, very simple to create client libraries from that discovery document. And using tools, that's very, very simple to generate client libraries for various different clients, including Android, iOS, and JavaScript. And it also has built-in authentication support as well. Because the application that you've written is running on App Engine, it has access to all of those services that we looked at before. So some sample code here. This is what it looks like to actually create an API using cloud endpoints. It's very, very simple. I don't want to look at the screen, to be honest. But basically, you take a class, a Java class or a Python class, you annotate it with an annotation called API. You can provide some parameters to it. A lot of this is inferred, though. A lot of this is basically using sensible defaults. And you don't have to provide a huge amount of information at all. But in this case, we're providing the name of the API, the version of the API, and having a version number also means that we can actually run multiple versions of the API in parallel. Then we annotate a method called submit answers with another annotation called API method. Here, because it can't be inferred very easily from the method name, submit answers, we're providing the HTTP method for the REST call, and we're also providing the path. But again, the path can easily be inferred by the runtime. A final parameter, a final annotation we use is named, and we're naming a parameter ID, which is game ID effectively, as a parameter used in our REST call. So that's actually effectively used in our path here. And in addition to that, we've also passed in a user object. And this is a Google API user service user object. And by doing this, we're effectively saying we want the runtime service to pass in the authenticated user, the user is actually making this call, into this method call. We don't have to supply it. Everything will be done for us. And then when we get that user, we can actually check to see if it's null or to see if it's a valid user. If it's null, then we can make decisions based on that and perhaps maybe say this user is not authorized to use this application. And finally, on the Android side, very, very easy. We basically use the client library to build an application. We get an instance of the library, call submit answers on it, and pass in the parameters, call execute, and that's it. That's the API consumed. And that's all you need to do to write an API using Cloud Endpoints on App Engine. It's very, very simple. So Cloud Endpoints development is also fairly straightforward as well. You have a number of options. This slide's a little bit busier, unfortunately. The first one here is using a command line utility that comes with the Java SDK called endpoints.sh. It has a subcommand get client lib that takes a package name, and that will generate a client library for you. And you can see all of the code here, ultimately ending up with this particular client library zip file. And you can do the same thing on Eclipse. So you write your code, you annotate your code, then you can, using the Google plugin for Eclipse, generate a Cloud Endpoint client library from that code. You can do the same in Android Studio, which is this one here. Google Cloud Tools, generate client libraries. On Mac OS, you also have tools for Objective-C, command line scripts you can use to build iOS clients. JavaScript is much simpler. JavaScript, you're basically using the standard JavaScript library for our APIs, and it's all declarative. You basically declare your API in some fields. Very, very simple to use. Then the next thing, the next feature that supports developing mobile backends on our cloud platform is push notifications. And App Engine supports push notifications through two different methods. One is APNS, the Apple Push Notification Service, and it does this using the Sockets API. There are patterns being published. I did have a link in my slides before. I should have probably kept it. But there are patterns that you use for communicating with APNS. It's very easy to upset APNS by sending too many calls at once, so you tend to batch them up. And the other option for Android is Google Cloud Messaging, which is implemented using GCM Server. And that's very easy to deploy in App Engine, which we'll see in the mobile backend starter later. And the kind of notifications we're talking about, and pretty much anything, you're going back the other way, you're sending messages from the server-side component, from the backend client, to the client device. Things like notification of new emails or other data on the server, sending game invites or receiving game invites from friends, and displaying toast messages with important pop-up information that the user should really know. Data and object storage is also important. We want to be able to store data, so user-level data. So when the user has some data, it could be preferences, it could be an image file, an avatar from, that they've uploaded, then we want to be able to store that data. And we have a couple of options here. So we have Google Cloud Storage, which is the bucket-based storage I mentioned earlier. All of the data in cloud storage is encrypted at rest. It's very easy to access. You can access all of the files in cloud storage via a URL. Then we have the Cloud Datastore, again, which I mentioned, which is the App Engine Datastore of old. This is better suited for finer-grained properties, such as maybe device registration or in-app purchases, those kind of things. Then also we have Memcache as well. Because the Datastore is a paid service, as is cloud storage as well, you probably want to make as few calls as possible to the Datastore. As few reads and as few writes as possible. And so by caching the data, you can not only improve performance and scalability, but you can also lower costs. And the final one I want to talk about is Prospective Search. And I kind of include this slide because I really like Prospective Search. I think it's really fascinating. So Prospective Search is kind of the reverse of traditional search engines, where you have a bunch of documents, a bunch of data, and you make queries against those documents and against that data to find matches. What you do with prospective search is you register queries in advance. You have the queries first, then the data comes in, and you say which queries match these documents. So it's exactly the opposite way around. So basically the queries are registered in advance of the documents, and that's why it's called prospective search. Documents in this case are really key value pairs. That's the important part of this. So they could be a Python dictionary, and we're going back to talking about the Datastore again, a Datastore entity. Datastore objects are all entities, they're basically bags of key value pairs. And a DB model class is basically an abstraction of that entity class in the Datastore. It supports some very simple queries, a query such as search for rows in the data, incoming data. Imagine incoming data streams or incoming documents. Search for the word rows in any field. You can do field-based queries where you're saying in the field author, search for the value rows. And we also have search operators, numeric search operators, and we also have and or not, very simple. So let's talk about the mobile backend starter, and really specifically in the context of Android. So the mobile backend starter also supports iOS, but we're going to talk about Android specifically. Have any of you installed the app? No? Oh, okay. Probably a good idea, actually. So what is the mobile backend starter? It's a ready to deploy sample cloud backend that you can use to develop your own backends with. It's ready to go. You can use it today. You don't have to make any changes on the backend side. And it also provides a sample client-side framework for both iOS and for Android, on which you can build your own applications. You can find out more about MBS here. The short form is V, big I, little b, little m, big V. And here's a quite complicated slide, quite busy slide, with lots of information about what the mobile backend starter offers. So here we have all of the features. So the ability to store data in the cloud, pub-sub messaging, push notifications, which we talked about, continuous queries, and that allows us to really leverage the power of prospective search by saying, I want to know about any data that contains this particular information that comes in. Google Authentication, because it's running on App Engine, it's an App Engine application, it's free to start, and because it's running on App Engine, it has the potential to scale infinitely. Those kind of things are at odds with each other. You're not able to scale infinitely on the free version of App Engine. That would be crazy. On the server side, we have the mobile backend starter component, which talks to the Datastore. And on the client side, we have the mobile backend client library, either for Android or for iOS. And these two communicate with each other over cloud endpoints in one direction, going that way, and either using APNS or Google Cloud Messaging Push, going that way. On the mobile side, well, actually, I mentioned cloud storage as well. You can also store data directly to cloud storage, actually bypassing this part completely. So you can actually get a URL, allows you to store data straight to cloud storage, or the URL to get data back from cloud storage. And what that leaves is the yellow box on this side, which is your application. And that's all you have to do, is write your own application code. But remember, this is a sample application. So let's kind of walk through how this works and see if the internet connection is going to really hold up for us. So the first thing you need to do to make this work is create a cloud project in the Google Developers Console. And I'm not going to walk through that step. It's very easy. Click Create Project, enter some information, the project name, project ID is automatically generated for you. Once you've done that, you have an empty project, and it makes a couple of suggestions. One of them is the mobile backend starter. You click on that, and I have some problems with my trackpad, so it may all go horribly wrong. And then you get the option, go back to the slides. You get the option to press deploy to deploy the mobile backend starter. Because it takes about 5 to 7 minutes to deploy, I've already done it in advance. So I didn't really want to go through that step. But it's already been done. At this point, you could redeploy it if you wanted to, or you can continue on to steps 2 and step 3. So now the application has been deployed. It's an App Engine application running on App Engine. So we can actually look at it in App Engine. And I called it jfocus-mbs.appspot.com. It has its own interface. It's a very, very simple interface for setting some settings. I should have actually changed that back to the lockdown. And because it's got an API, we can actually browse the API as well. I need to open another tab for that. I go back to jfocus-mbs.appspot.com, and it has this extra path, this administration path, _AH API Explorer. Now that's not part of the application itself, it's part of the runtime. And it really gives you access to the API so you can see what it does. So it's a little bit difficult to see. Let's make it a bit smaller. Can you guys see that? So here we have our API, mobile backend API with a very interesting description. This is an API, which isn't very much use to anybody. And then we have all of the methods that are exposed by that API. And most of these, as you can see, are pretty much CRUD operations. We have a couple at the top here that allow us to store data into cloud storage, the blob calls here. And we can actually click on one of these and make calls to that API by providing the required information, such as the kind name in this. Entities in the Datastore have a kind, and also an ID of an object, and you can get that ID. I can't do it because the application's actually been locked down, so the API's Explorer doesn't actually have access or authorized access to the back end. You can also make authenticated requests by clicking that button there. So we've done that slide, that slide there. And when you make a call, it looks kind of like that. You make the request, you provide, it passes the information that you pass in here, and you get a response back. That's basically just testing the API out, just kicking the tires. But this infrastructure, the API's Explorer infrastructure, is accessible for all of our APIs. You can use it for the Maps API, for the Google Plus API, etc. The next thing you want to do is open up the application so you can send any kind of request to it. And that's very simple as well. You go to the mobile backend starter user interface that we looked at earlier, click on open, click on save. And now that's in development mode, and you can now make any kind of requests to the backend. This is perfect for development. See what the next slide, see what the next slide is. So the next step in setting up the mobile backend starter is getting a sample client project. Now this could be either iOS or Android. It's pretty much the same rules apply. Obviously the development process is a little bit different for iOS. But you basically download the Android client project, and it has an option in the user interface to download either, up here. And to run that code, you need to provide the Google APIs, including GCM, and you need Android level 15 or above. Once you have that code, there's a file called const.java that has lots of parameters in it that you need to be able to make calls from the client to the back end. But it's incremental. We're going to go through the steps one by one and what you need to do to actually make that work. Once you've set that, you can build a project and you have a very, very simple cloud application at your disposal. No, okay, stay with the slides. So this is this file called const.java, and it contains all of the constants, all of the declarative, effectively, configuration you need to supply to make this application work. The first one we're going to supply is the project ID. So this is the ID of our cloud project, and it's jfocus-mbs. Very, very simple. And what that effectively does is allow the client application to find the App Engine application. The App Engine application is called jfocus-mbs.appspot.com. So now, with this information, it can find the APIs that this exposes. The next thing you need to do is notifications. So we want notifications. We want to send messages back the other way. At the moment, we can send messages from the device to the mobile backend starter, but we can't do much with them. We want to be able to send messages backwards. So what we do is first, going back to our console again, the first thing you have to do is enable the Google Cloud Messaging API. And we scroll down here. This is APIs in the left-hand side here. APIs and auth, APIs. Google Cloud Messaging for Android, and enable that. Yes, I accept the terms of service. I have done many times in the past. Then you need to set credentials. You need a API key, which will identify the backend starter to Google Cloud Messaging. And that's very simple to generate. Create a new API key, create server key. In this case, we're going to say open to any IP address, and we generate the key. Oops. That comes back. We take the key. It's got a hyphen at the end. Interesting. Take that, and then we can enter that into our mobile backend starter configuration. First, we enable Google Cloud Messaging, and we enter the key. Click Save, and now we basically identified the project to Google Cloud Messaging, or the backend starter to Google Cloud Messaging. What does it? Sorry?
I think you missed part of the key string.
Did I? Okay, it doesn't matter. We're not actually going to run this one, so we can use the one we've already got running. So thanks for pointing that out, though. Okay, so we've done that step. So going back to const.java. Once we've done that, we need on the other side, on the client side, to provide the project number. So we had this concept of a project ID and a project number, unfortunately. And the project number identifies a Google Cloud project, APIs project, effectively. And this is effectively saying on the client side, when it talks to GCM, I want to listen to messages from this project. So that's what we do. We change that value there. Do I need to look at anything else? No, that's it. So let's go on to the next slide. So that's effectively this here. On the server side, we set the API key, and this effectively identifies who's sending messages to Google Cloud Messaging. And on the other side, we set the project ID, which is basically saying, I want to listen to messages from this project. And the one thing I was going to show you was where you get the ID from, the project number, and that's there. So in overview, in the Cloud Console, you had the project number at the top. Hopefully one day they'll do away with one or the other. Then, once you've done that, you're now able to send messages from one device to all of the other devices. The mobile backend starter can do whatever it wants, but in our little simple application, effectively what you'll do, you'll send a message, and it will be propagated to everybody else who's using the application. But what if you want to identify the person who sent the message? So in that, you're going to use authentication. So authentication gives us several benefits. The first, it allows us to establish a very strong identity for our Android client. Next, it also allows us to lock down access to our APIs to specific clients. It also allows us to associate users with their data, with their messages and such like when they're persisted. And it also allows us to share user data across multiple devices. So when a user goes from one device to another, they can see the same state. It also allows us to share messages with one user or with multiple users, selected sets of users. So this is 1Password. Anybody use 1Password here? It's not very popular in Finland. I use this. I have about 60 passwords, and they're all in 1Password. And I hate passwords. How many people like passwords? Okay. That's the one time I've had nobody put their hand up. That's fantastic. Nobody likes passwords. Passwords are horrible, but we have to manage them. So what we really want to do is move to a world where we don't have to do that anymore. And obviously, using a third party to do our authentication for us is the way forward. Obviously, we had to have some level of trust with that organisation in able to be able to offload that process. But in this case, on an Android phone, it's very simple, or at least a stock Android phone, maybe not Kindle Fire. You can then, basically, when you open an application, you can say, I want to use this account to authenticate. Very, very simple, very, very cool. But there is one little problem. We get this OAuth 2 consent screen. OAuth 2 always has this consent screen. Whatever you do, whenever an application wants to do something on your behalf with an application, it wants you to say, yes, I'm okay with this. So it pops up this OAuth 2 consent screen. You can either accept or you can cancel. It's standard and it's very, very powerful. It's useful for third-party applications, but it's not useful for our Android application. Really what we want to be able to do, because we developed the client, we developed the server, we just want to bypass this process altogether. And we can. So this is a tale of two client IDs, effectively. The first is a web client ID. And what this does is it establishes that one developer is responsible for developing both the backend and the client. And that removes the need to have an OAuth 2 consent screen. This value is required in both the backend configuration and in the Android application. An Android client ID, on the other hand, strongly identifies a mobile application from its package name and its SHA-1 fingerprint, which is stored in either the debug or release key stores. This is a calculated value, and it represents effectively the signature of the application that's running on the device. This is required in the backend configuration only. So basically we have this key that identifies specifically this application on the device. And the way we generate those, again, is very simple. It looks complicated, but it's not compared to writing very complicated amounts of code. Here we create a new client ID. We can say web application. We provide the URLs and the callback URL here. And then we create a client ID. I'm not going to do it, because I don't need to actually create one now. We have one in the example. And we can also create one for Android as well. Go to installed application, select Android. Oops, excuse me. And there we can enter the package name, and we can enter the SHA-1 fingerprint. And then we can generate the Android client ID from that information. Once we have that, we go to our configuration again for the backend. And we go from being open completely to saying secured by client IDs. And here we have two fields for our Android client ID and for our web client ID. And that's where you provide that information. With me so far? It's after lunch, isn't it? You're all falling asleep. On the client side, you've done the configuration on the server side already, so now you need to do the configuration on the Android side, on the client side. You don't have to worry about the Android client ID. It knows what that is. That's it. That's its signature. But for the web client ID, you need to tell it what the web client ID is, and that's that string there. So now we've almost completed our const.java file. At the end, there's an option to say, is auth enabled? You enable that to true, and you're now able to do authentication using the mobile backend starter. And in summary, that's what this looks like, the first one, anyway, the web client ID. We create the web client ID on the server side, add that to the backend starter, and then add the web client ID on the client side as well. And we're effectively saying this is the same developer. We won't get the OAuth 2 screen anymore. And finally, the Android client ID, which is generated on the client on the server side, but which represents the application signature on the client. The Cloud Guestbook application, which none of you are using, very simply stores messages on a user basis. The notifications, the push notifications, are all done through GCM. There's no polling, no updating of the UI through polling. Very efficient. Authentication, we're allowed to propagate the Android user, the logged in Android user, through the whole process flow. And we can hide the OAuth 2 consent screen. So, coding, how long do we have? Oh, okay, excellent. So when it comes to coding couldn't really be simpler. We showed you an example earlier of like 3 lines of code for inserting some data into a data store. So the key to all of our coding is the cloud callback handler. And we have to implement the callback handler, and we're going to use it in lots of different calls. I'm only going to show the creation of it once. It has 2 methods. It has onComplete and onError. You have to implement the onComplete processing logic effectively. But once you've done that, it's very, very simple to use. You create an instance of cloud backend messaging. Now, we have quite a complicated hierarchy of objects. We have a synchronous version of a cloud backend. We have an asynchronous version of a cloud backend. And we have this cloud backend messaging subclass. We create that. We pass in a context, in this case an activity. And then we can very simply call subscribe to cloud message on that object. And we pass in a topic. This is a topic we're interested in. It's not an actual message. And we pass in our cloud callback handler, which will be invoked when anything matches, when any messages that come along that match that topic. You okay? We had the slides anyway. So. Cloud backend messaging again. We're going to create a new one. We're going to publish this time. Pass in an activity again. And this time we call create cloud message, passing in a topic. Oh, no, sorry. Yeah, we're creating a cloud entity, but we're calling a helper method on cloud backend messaging, passing the topic to say, give me an entity of this particular topic type. Then we're putting in some data. This is basically just an object at the moment. We can put in data. We're saying, chat message, this is a chat message about how great JFocus is. And how great is JFocus? Is it great? And then we can call send cloud message, passing in the entity, and that's it. We've published. Now, our call on the other one will match that incoming data, and we'll send a notification to our on complete callback method, and we're done. Continuous queries. So again, this leverages Prospective Search, and also this is very simple. This isn't part of the client application that we provide, but it's very simple to implement anyway. In this case, you need an asynchronous version of the backend. You're never really going to use a synchronous version. You're not going to block waiting for some loosely connected service. And again, we pass in a context, an activity in this case, and we create a thing called a cloud query. We're going to give the query a name. We're going to call it My Events. This isn't a topic. This is a name for our query. Then we're going to set a filter. We're going to say, I want to filter on the event field called JFocus. Then we're going to set the scope of that query to future and past, which is a little bit intriguing. And what this effectively allows us to do is to say, I want to register an interest in messages that come in that contain this data, but I'm also interested in the messages you already have, things that have already been registered. So return them back to me as well. So then we call cloud backend async.list, pass in our query and our callback handler. The callback handler will be responsible for managing any new updates that come along. But because we also registered for past events, we may get back a response that contains a result set of those past matches, and that would be a list of cloud entities. Then storing and retrieving data. This goes back to the code we looked at earlier. You need to get a cloud backend async again. Then you have a bunch of CRUD calls you can make on that cloud backend async. Here we're going to create a new cloud entity with a topic of guestbook. We're going to stick a message in it. It's basically just a bag of properties now. And we're going to get the message data from a text field in our user interface. And then finally, we're going to call insert on the cloud backend async to effectively insert this data into the data store. Because we're going to be authenticated when we do this, we're going to actually have additional data that identifies the user who owns this particular message. Cloud storage is also very straightforward. I'm not going to go through it particularly, but basically you're going to get a URL to which you can upload your data. And also if you want to download the data, you're going to get a download URL. It also supports other CRUD operations. So as well as insert, you also get, update, and delete. It's very much the same process as the previously described insert. And customizing the backend, it couldn't be more simple because it's all open source. It's in GitHub. If you go to GitHub and find the Google Cloud Platform user, under Solutions Mobile Backend Starter Java, which has got this short URL with this interesting little I on the back. No, it's a little L. I think. And I hate this. I really think we should stop generating URLs that have I's, big I's and little L's in them because they're unreadable. So you probably want to try that out or get the size and click on the link. We also have an API reference document that's not absolutely perfect at the moment. It's very usable. But that describes the API that we've talked about on the previous slides. And that's it really for the talk. So we have time for questions, I think. Yeah. So we have 10 minutes for questions. There's a guy who works at Google in the back there asking a question.
What's the price model?
Price model.
Yeah.
So the pricing is all going to come down to individual cloud services. Okay. Yeah, please.
What's the price model for the backend?
Okay, so the pricing model comes down to the Google Cloud services you're going to be using. So in this case, we're using App Engine, which is free to use to begin with. You don't have to pay for using App Engine to begin with. You get a limited amount of quota per day that you can use. That's reset every day. Once you exceed that quota, you can no longer use any more of that quota. So that card, at that point, you put your billing information in and you'll be charged. But we have different charges for different quotas. We have charges for number of instances. We have charges for other operations you perform within App Engine as well. For things like the cloud data store. You get charged for what you're storing, and also for ingest as well, I believe, and that's all. So pretty much that's all you'll pay for these particular services. Yeah? Okay, thanks.
A quick plug from the back here, just to say that on the Google stand, you can find some App Engine and Compute Engine credit as well. So do pop round there a little bit later.
Right, okay, so I did forget to put my slide in. So what's the code?
I haven't got it with me, so
Okay, so
visit the stand.
So basically, I should have had a slide for this, but we basically got a cloud credits, a credits pack. Gives you $1,000 worth of credits for App Engine, $1,000 worth of credits for Compute Engine, our infrastructure as a service offering. And basically, what we have to do is go to a URL and enter a code. You can get the code from Rupert on the Google stand. If not, you can find me, and I'll find the code and I'll give it to you as well. I should have put it in my slides, but I do apologise for that. But yeah, so that's a good way of getting up and running with the cloud. $1,000 worth of credits for both of them. Any more questions? Yeah.
All right, so I haven't actually done any Android development or App Engine development, but I'm a little bit curious. Should I consider mobile backend starter a separate API, or is it just a way of getting started with App Engine? Like, can I evolve a mobile backend starter app into a full-blown App Engine app?
I don't think it's the best way of getting started with App Engine. There's better ways of getting started. We have lots of tutorials, lots of videos and such like. Everybody heard the question? Yeah. So basically, I don't think it's a very complicated application. So you're going to need to have some advanced skills, not necessarily in App Engine, just in development generally, to be able to modify it. Although looking at the code, it's fairly obvious. It's very easy to see the API classes and such like. So it's not that complicated. But I don't think it's the best way to get started with App Engine. We also have a thing called the Cloud Playground. So App Engine has this thing called Cloud Playground. You can effectively go to a web page and interact with App Engine with code in the web page. It will run it for you on an App Engine instance somewhere in the cloud. So you can actually see the results of your changes to your code immediately.
So if I make an Android app, the mobile cloud endpoint starter isn't necessarily the best way to get a backend up and running, if I know that I'm going to need something.
I think it's the best way to get a back-end up and running, but not necessarily to do Android development.
Sure.
It's a very good starting point, but it does work as it is. I don't think it's probably particularly scalable as it is. It probably needs some modifications, but it shows you great examples of all the things we looked at today: storing data, push notifications, exposing APIs. It's a perfect example for all of those. Thanks a lot. Cheers. Any more questions? Okay, so you can find me on... Oh, question there.
This, what we're talking about now, is for building Android apps and iOS apps.
Yep.
But I guess, the Google App Engine have the same kind of services for making more like normal web services.
Yes.
So you're not that tied to mobile apps, which you are in this case, as I see it, or...
Also, the backend starter has no web interface. Obviously, App Engine development was traditionally web-based, but with the advent of cloud endpoints, that makes it really, gives you the ability to develop applications for not only web-based clients, but also for Android, iOS, and JavaScript. Even just any kind of client that can make REST calls can now consume services of App Engine. So it's not limited to web anymore. And you can actually take your existing web application, add an API to it, and then expose that information to native Android clients very, very simply. So I think that's a really good way of doing things as well. So if you have an application, a web application today, you can extend it by adding features that will allow it to be consumed by other clients on other devices. Yeah?
Thanks.
Thanks a lot. Cheers.
Hi, can you use it, how's the ping? Can you use it to play, for instance, a distributed game where it's semi-real time, or is it just for notifications?
Well, that's interesting. So one of my slides that I used last night at the Vardin meetup had Ingress as an example. How many people know about Ingress? Have you heard Ingress, the game? So Ingress is a massively multiplayer online game, a pervasive game. where basically users play against each other. We have two teams, the Resistance and the Enlightened. There are millions of people playing this game across the world, and it's all implemented on top of App Engine. It has social aspects. It allows people to talk with each other or to groups of people. It uses the Google Maps API to give you this map of this crazy world that has all of these things that you can capture, these portals that you can capture. So I think Ingress, and given its scale, demonstrates that App Engine is a very good platform for building these kind of games. Some kind of games like a first-person shooter or an RPG probably wouldn't be suited to App Engine. You'd probably want to spin them off into game servers running in the cloud on virtual machines. But for other games, I think App Engine is perfectly suited, and the mobile backend starter is good as well. Okay, cheers. Thanks a lot. Any more questions? Okay, so well, thank you very much for coming. If you want to find me, I'll be out there on the Google booth somewhere, or I'll be sleeping. I was on a boat last night. We got in at 5 o'clock this morning. We were woken up at 5 o'clock this morning. It's crazy. I'm banging on the door. So yes, I may be asleep somewhere, but if you see me, just wake me up and I'll do my best to respond to your questions. Thank you so much for coming today. Enjoy the rest of JFocus.